Most students hear the word op amp and immediately panic. They think it's complicated, full of equations, and impossible to understand. But today, I want you to forget all of that, because an op amp is basically a very angry manager. Imagine a manager who has two eyes. One eye is called the non-inverting input, the plus sign. The other eye is the inverting input, the minus sign. His only job is to compare these two inputs. If he sees even a tiny difference between them, I mean something like 0.0000000
2 hours later.
0.00001 volts, he completely overreacts.
What is this difference? Make it big.
And that's exactly what an op amp does. It takes a very small voltage difference between the positive and the negative and multiplies it by a huge gain, sometimes over 100,000. So yes, this manager has a very loud voice. So you might be wondering, why do feedback exist? Now here's the problem. If we let this manager work alone, he will either scream at the top limit or go silent at the bottom limit. In electronics, we call this saturation. So, what do engineers do? We add feedback. Feedback is like bringing HR to the room. It tells the manager, relax, calm down, you don't need to exaggerate everything. With feedback, the op amp becomes predictable, stable, and useful. Without feedback, it's chaos. So what can an op amp do? Depending on how we connect it, the same op amp can do many jobs. If we want to amplify a signal, it becomes an amplifier. If we want to just copy the voltage, it becomes a voltage follower. And if we want to make a decision, so much as is this voltage higher or lower, it becomes a comparator. The most important idea to remember is that an op amp does not care about absolute voltage. It only cares about the difference between its two inputs. Small difference in, big difference out. So the op amp is not scary. It's just an extremely sensitive device that hates difference and loves feedback. Once you understand that, most analog circuits suddenly become sense.